Okay, you're right. Welcome to your tutorial on Pythagoras' theorem. Today we're going to have a look at what Pythagoras' theorem is. I know you guys already have a bit of an understanding from your assignment, but we're going to look at it in a bit more detail. Please be impressed by Pythagoras here wearing a party hat. Because I spent 20 minutes trying to Google a picture of Pythagoras in a party hat. Couldn't find one. So spent 10 minutes photoshopping this little bad boy for you. So, woohoo! It's party Pythagoras. Okay, Pythagoras' theorem. What the hell is it? Well, long story short, we use Pythagoras to calculate the lengths of sides in a right-angled triangle. That's why we use it. Why the hell would you want to use it? I'm going to show you a few examples next lesson of where we actually can use it helpfully. But this is the idea, that we use it to calculate the length of the sides. Now, there's a relationship between the sides in a right-angled triangle. It's only for right-angled... Oh, it's a giant marker. Whoops. It's only for right-angled triangles, okay? And the idea is, in any right-angled triangle, the square of the hypotenuse, which is the side opposite the right angle, is equal to the sum of the square of the other two sides. Now, there's so much information in there that doesn't make sense. So I've highlighted the word hypotenuse. Let's have a look at what the hypotenuse is. Okay, the hypotenuse is always opposite the right angle. So no matter what side my triangle is, okay, it's always the one opposite the right angle. Now, coincidentally enough, it's also the longest side, but don't use that as a judgment. Find the right angle and then say, okay, the one opposite is the hypotenuse. So in this case, this guy here is the hypotenuse. In this case, this guy here is the hypotenuse. In this case, this guy here is the hypotenuse. In this case, this guy here is the hypotenuse. It's the one always opposite the right angle. So don't look at a triangle and think, oh, that one's the longest. Look at a triangle and say, where's the right angle? Sweet. If that's the right angle, the one opposite's going to be the hypotenuse. Okay, so you have to know where the hypotenuse is because that's essential to know if we're looking at our formula. Now, the other part of this definition that doesn't really make sense is this square thing. It's saying in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. What the hell are all these square things? Well, imagine a right-angled triangle here. Okay? Boom, boom, boom. Okay? And I know you guys have seen this. C squared equals A squared plus B squared. I know that you've always labelled the hypotenuse C, and I know you've labelled the other sides A and B. Now, what does that actually mean? Well, imagine that the side length B over here, okay, say that's 3 centimetres. I've just picked a totally random number. Okay, if that side length's 3 centimetres, okay, that would mean that if there was a square coming off it, this would be 3 centimetres. So this would be 3 squared, which would be 9 centimetres squared. That would be, 9 squared. 9 squared. Let's just say 9. Let's say 9 because it'd be 3 squared. Okay, that'd be 9. Let's say this one here, this length here, I'll pluck another random number. Okay, this would be 4. Okay, that means if it had a triangle coming off it, it would be 4 by 4 or 4 squared. Okay, what we're saying here with the squares is the sum of both of these is equal to the sum of that. I can then use that information to find this little length in here. Let me show you. So, what I've done is I've grabbed this square here and I've put it out here. Then I've grabbed this little square in here and I've cut it up into pieces. I've cut that bit and put it here. I've cut this bit. I've got and put it over here in Photoshop. And then these two little bits, I've put them there and there. Okay? Long story short, I've cut up these two squares and put them on the side here. Watch what happens. Slowly as I draw it over, I'll notice it actually fits over my purple circle. So it's the exact same size as my purple circle. That's what I'm saying when I say in any right-angled triangle, the square of the hypotenuse is equal to the sum or the addition of that plus that. That's what I'm trying to say, guys. That's what that statement says. Okay? Then, once I find that squared plus that squared, I can get this whole entire area for that. Most of the time I don't want the area of the square, so if I've got the number squared, I find the square root in order to work out just the side. That's what the squaring is, though. That's what you're actually doing. You're squaring that little number in there, you're squaring this little number in here, working out all of that, then finding the square root in order to find out this side length here. So, let's have a look at a few examples. Okay, c squared equals a squared plus b squared. That is my formula. Those numbers can change, but it's saying this squared, like I've just looked at it, the example, is equal to this squared plus this squared. It will always work in any right-angled triangle, no matter what. This is my basic formula. C squared equals a squared plus b squared. So, let's look at this example here. I've got this side, I've actually just done this for you. I've got this example here. I've got a side of 3 and a side of 4. Okay, now I know that c squared, or if I have a square off here, it would be equal to 3 squared plus 4 squared. Okay, and again, I'm finding the squares off either of these sides. Now, I know that that will be 3 squared is 9 and 4 squared is 16. So the square that's currently coming off this side, or the square that's coming off here, is going to be 25 centimeters, okay? So the square coming off my hypotenuse currently is 25 centimeters squared, okay? Oh, I'm assuming centimeters, sorry guys. I didn't put measurements on it, but I'm just said centimeters. So it's 25 squared, the square that's coming off the hypotenuse. I don't really want to know that though. I just want to know the side length. So in order to find the side length, what I do, so in order to find c by itself, what I do is I find the square root of 25, which gives me 5. So, I don't divide it by 5, I don't divide it by 3, I don't do anything like that. If I've got that squared, the opposite operation in order to get just the side length, if I have a square, is to square root it. So that gives me my answer of 5. Now, what the hell do I do if, for example, I've given the hypotenuse and I'm missing one of the sides I usually use to calculate it? How the hell am I meant to work it out then? Oh, that's a bit weird, isn't it? What can I do to actually work that out? Let's try substituting it into the formula. So my formula says that c squared equals a squared plus b squared. Okay, let's get in what I've had. 10 squared equals a squared plus b squared. Oh, sorry, whoops. Doesn't really matter which way I call it. I'm going to call it, for the sake of this exercise, okay, I'm going to, okay, let me just get rid of this, blah, 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 blah. Oh, okay, I'm going to say that it is a squared minus 8 squared. Okay, now, that's weird. But 10 squared equals a squared minus 8 squared, they're on the wrong side. Oh, wait on, I see what I can do. If I'm looking for this little guy in here, certainly I could just go 10 squared, but instead of adding, I'll subtract this side, 8 squared, and that will give me my a side, okay? So before I added them together, in theory now, if I have the longer side length, I can subtract the other one to find a squared. So a squared would be equal to 10 squared, which is 100, minus 8 squared, 8 eighths are 64, okay? So a squared would be equal to 36. Now, what I've technically got now is the square that is coming off my a side, which is 36 squared, okay? I've got the square. I don't want the square, I just want this little side length in here. So in order to work that out, I work out the a equals the square root of 36, which equals 6. Okay, and that's it, guys. That's how you work it out if you have the hypotenuse but not a side, and then if you have two sides but not the hypotenuse. It's pretty cool, Pythagoras. We can do lots of really, really fun stuff with it.